Hey everyone, today we're going to continue working on calculus problems. Well, from yesterday, we have already seen how to take the derivative of a function f of x raised to another function g of x. So we already proved the results that why the trick that we were using on covering one part and just take the derivative of the other parts will work. So today we're going to play around with that idea, and we're trying to compare the first derivative between the product of three functions versus the exponent in three functions. So before we move on and start the calculations, let's pause the video for a bit and give it a try by yourself. Also, before we start moving on, let's take a guess how much more time I need to spend to figure out the final form of the exponent versions versus the product version. Are you ready for it? All right, let's start with the easy one. So we're going to first take the first derivative of product of three different functions. By what we have known about the covering method, we can just get three parts, right? This time, I'm going to show, if we don't know about that method, how we're going to do it. In other words, how we can actually show that we will actually get three parts in total. So first, let's try to use the product rule. So I'm going to treat the second and the third function, g of x and h of x, to be one big function, namely some k of x, okay? Then in that case, by the product rule, the first derivative of the product of two functions will then be the first derivative of the first function, namely f prime of x, times the second function. In this case, it will be the product g of x times h of x, plus the first function f of x times the derivative of the second big function. In this case, it will be the derivative of g of x times h of x, like this. Good. So for the first part, there's nothing we can actually do besides removing the brackets. So we get f prime of x times g of x times h of x. Now for the second part, we still need to figure out the derivative of this product here, g of x times h of x. Since we have a product, we're going to use the product rule one more time. We're going to get f of x times the quantity right here, which is the first derivative, g prime of x times the second part, h of x, plus the first function, g of x, times the first derivative of the second function, h of x. So if we try to multiply the f into the two parts inside the brackets and distribute it, we will get our final answer. F prime of x plus times g of x times h of x plus f of x times g prime of x times h of x plus the last term, f of x times g of x times h prime of x. And that is the result for the derivative of product of three functions. And again, I'm going to remove this because it doesn't matter. Great. And perhaps most of you have already seen this before. In fact, we can just think it like the covering method, that we're going to cover the other two parts and then take one function at a time. And since we have three functions, we'll end up with the sum of three parts, three terms. Good. So we already finished the first problem. So let's jump into the more challenging one. All right. Now we're moving on to the second problem. This time we're going to take the derivative of the three functions in exponential form, okay? F of x raised to g of x raised to h of x power. And since in the video yesterday, we have already shown that the trick that we are allowed to just take one function at a time. Let's see what we can do. So in last video, we showed that we were allowed to do that if there are only two parts. But this time we have actually three functions. So again, before we start, I'm going to group it this way, so that now we can treat everything inside of the green brackets as one big function, again, namely k of x. So now we just have to find the derivative of f of x to the k of x exponent. So since we already know how to do it, but the formula itself is actually long, so I'll just do it again using the covering method. So first, let's deal with the base f of x. In this case, we'll treat the top part, k of x, as a constant. And again, what's k of x? It is g of x to h of x power. So according to this, since we're talking about the base as our variable and the exponent is temporarily a constant, by the power function derivative, we're going to subtract 1 to the exponent and then multiply with the original exponent part, g of x raised to h of x power. But of course, this is not done yet, because now we need to look at the base, which is f of x, not just simply x. We then need to take the chain rule. We need to take the derivative of f of x as well. So this already finished the first part. Next, we're going to deal with the exponent part, meaning we will now get f of x raised to the k of x power, and again, k of x is just g of x to h of x power. Then by the exponent function, the derivative of it is the original function itself times The ln of the base, in this case, it will be f of x, of course. And of course, you can put absolute value or however you want. It doesn't matter. We're not worrying about it right now. But then also, we of course need to take the chain rule for the exponent part. Because once again, suppose if it's not x, then let's say if it's x squared, we also need to take the derivative of x squared and multiply it in order to get what we want. So in this case, we need to multiply with the first derivative of k of x, like this. And don't forget here, ln of f of x is is not enough. Most of the time, when we have the base, we're just saying it as a constant. So let's see, do I have to change it? No, we don't have to. Good, because again, this time we're treating f of x as a constant term, even though it's actually a function. We're temporarily saying it as a constant, so we're only multiplying with ln of a constant, so we don't have to take the derivative of it. Good. So in this case, let's try to do a little bit further because we're still not done with this part, the derivative of g of x raised to h of x. So let's put everything together first and see what we'll get at the end. So for the first term, we get the following expression times g of x raised to h of x times f prime of x plus, now the second term, we have, of course, f of x raised to g of x raised to h of x times ln of f of x times, and we finally need to figure out the first derivative of this ugly product k of x. Not product, exponent. So let's see. Using this one more time, we will get, let's see, with the idea we're going to get g of x raised to h of x minus 1 power times the first derivative of g of x, which is g prime of x, then plus, wait, almost forgot, multiply with the original exponent h of x. Now we are going to do the second part, plus g of x raised to h of x power times the derivative, the ln of the base g of x. Now we're going to multiply with the derivative of h of x, which is h prime of x here. And clearly I'm running out of room, but it doesn't matter. So let's see. Now we can try to collect something that are similar and try to factor out something nice. So we can see that here, the first big term has f to g power to h power. And for a second big term, we also have that. Let's pull it out. We get f of x raised to g of x raised to h of x power. Then for the remaining parts, we now get g of x raised to h of x power times f prime of x over, and why do we get over? Because remember, we have a minus 1 here. So this is equivalent to say f to the g to h power all over f of x. So if we factor out the big exponents here, we will end up with 1 over f of x power x function. Good. So for the second part, let's see what we'll get. Well, first, we still need to multiply this into both terms to get ln of f of x times this product here, which is g of x to h of x minus 1 power times g prime of x times h of x plus, and if we distribute this again, we will get ln of f of x. And I know this notation is actually not clear, so I'll put brackets in it so that we're not going to multiply everything else with the f of x before we take the natural log. So we have the natural log of f of x times, again, g of x to h of x power times ln of g of x. Okay, again, I'm going to put the brackets here, times the first derivative of h of x, which is h prime of x. And at the end, we're going to put the curly brackets in it. And that is it. We just finished figuring out what the derivative of f of x to g of x to h of x power is. So I actually don't know how much time I spent. Well, clearly it has to be a lot longer than the first problem. But if you guys watch the video, you guys can now calculate for me how much more time I need to spend to figure out the derivative of the second problem than the first problem. And that is it. Pretty cool, huh? I hope you enjoyed this video. And please don't forget to like. And if you want to watch more of my videos, go to subscribe my channel, and you can find more other videos in my channel. So also don't forget to turn on the notification so that whenever I have new videos, you'll always see it. You will not miss anymore. I'll see you guys next time.